Hello, everyone. My name is Lauren Moore, and this summer I worked in Professor Christoph Reinhardt's Sustainable Design Lab, researching parametrized templating of the U.S. building stock for embodied carbon estimation. In the fight against global climate change and reducing CO2 emissions, is a challenge that has received a lot of attention from various government agencies and organizations alike, such as the Carbon Leadership Forum and the U.S. Department of Energy. It is known that buildings alone account for 41% of global emissions, and although we've seen a slight decline during the pandemic, reports show that emissions need to halve by 2030 in order to be on track to reach 2050 net zero carbon building stock goals. Building emissions are generally categorized into either embodied or operational carbon. Embodied carbon is the carbon dioxide emitted during the manufacture, transport, and construction of building materials. Operational carbon refers to the carbon emitted during the operation of a building, which, for instance, is the heating and cooling, water use, electricity, and appliance use. In the past, carbon reduction efforts have focused solely on operational carbon. However, studies have shown that 49% of buildings' carbon emissions are due to the embodied carbon contained in the structure. In order to address these issues, a proactive approach is needed because once a building is constructed, the embodied carbon emissions are fixed in place and cannot be improved. This can be viewed in contrast to operational carbon emissions, which can be reduced with things like efficiency renovations and introductions of renewable energy sources. When considering a building's total life cycle, operational carbon accounts for only a small portion, meaning we must have considerations to the extraction, transportation, and manufacturing of raw building materials. The growing recognition of these issues leads to a question of how to track and reduce embodied carbon emissions. Building industry professionals need better data and guidance on how to implement low carbon methods in practice, and this is what we are hoping to address with this research. So how do we accomplish this? We are looking to develop a workflow that's able to accurately estimate the embodied and operational energy of buildings. And we would like to make it parametric so it can be applied to any buildings in the United States and eventually used to model cities. Prototypical buildings have been formed to address questions about operational energy in the form of energy templates. We are looking to create similar templates which are able to quantify both embodied and operational energy. In order to do this, we first need information on what buildings are currently in the US building stock. Fortunately, the Department of Energy has developed a list of 16 reference building types that represent approximately 70% of the commercial buildings in the United States. For my research, I chose to focus on mid-rise apartment buildings because residential buildings are a significant contributor to total building emissions, and also for simplification purposes because apartment buildings have repeated design trends. We took surveys of apartment buildings, which we gathered using construction bidding websites, and used these plans to determine the structural makeup of the apartment buildings. Here I have shown the similarities between the flooring in various apartment buildings to demonstrate the repeated modules I referenced earlier. For simplification of this presentation, I'm focusing on one specific module in the King Memorial apartment building located in Atlanta, Georgia, which you can see outlined here in red. A 3D rendering of the structural system of the apartment building was developed using Rhinoceros, a computer-aided design software, building elevation were traced to develop 3D models of structural elements, and combined with Grasshopper, a virtual scripting environment that allows for parametric manipulation. The workflow enables us to produce a volumetric output of each material, and the parametrized geometry and material type variables could be modified to the specifications of all floor plans with similar layouts. These volumetric outputs were linked to carbon emission coefficients and were used to estimate the embodied carbon and the contents in the structure, which you can see here. The results were surprising because even though so for this apartment building, the concrete elements proved to have the largest contribution to the embodied carbon of the structure. This was surprising data because in terms of quantity, timber significantly outweighed concrete. However, because of the embodied carbon contribution of concrete, it was a much larger contributor than timber in the structure. The data collected from these workflows are useful for influencing design decisions, determining whether to retrofit buildings or build new, and to serve as a baseline which can track progress towards sustainable design goals. The next step of this research would be to upscale the project to eventually model entire cities. Some limitations to the research include determining the structural materials of existing buildings in the building stock and quantifying the embodied carbon that is not from the structural elements. As we learn more about embodied carbon in United States building stock, we can make more informed design decisions and obtain our goals of a more environmentally conscious building sector. Thank you.